All right, you guys. So in this last unit, we're going to talk about triangle congruence theorems. So our essential question is, how can we use SAS to prove triangle congruence? So some vocab that I should introduce first is what are congruence theorems? Congruence theorems. So mathematicians have been at this whole math thing for a very long time. We've noticed patterns in pyramids, we've noticed patterns in triangles, and you know what? Triangles is actually like the most in-depth feature of geometry because it's a thing that mathematicians have been using most often because triangles have so many patterns and other sorts of things in them. And so they've used those patterns over and over again to solve real world problems. It dates all the way back to Pythagoras and the first mathematicians in the world. So congruence theorems are ways to prove two triangles are congruent without knowing every single angle measure and every single side lengths. Okay, so congruence theorems, they're just a way to prove triangles are congruent without all of the pieces of the information. So today we're focusing on SAS. SAS stands for side, angle, side. Okay, in a triangle, there are 6 different possible congruence theorems, and not all of them create congruent triangles. But today we're going to talk about side, angle, side. So the order of each of these matter, because if you notice, side, angle, side, and side, side, angle have the same letters, like they both have 2 sides and 1 angle, but the order in which they're presented really matters because this A in the middle means that the angle has to be right in between the 2 sides. So order matters. Okay, so if I have a triangle and I have a second triangle, and I know that this side is congruent to this side, I know that this side is congruent to this side, then the angle that's in between has to be right in between those 2 sides. The only angle that's in between those 2 sides is this one right here. Okay, I can't use any of the other angles. The angle has to be the included angle between the 2 sides. I paused because I wanted to make sure that I had the right vocabulary. This is called the included angle. Okay. All right. So now we know what congruence theorems are. We know what side, angle, side stands for. Let's talk about the side, angle, side congruence theorem. Okay, and it's kind of wordy, so if you want to reword it in your own words that make more sense, or if you want to like draw a diagram, whatever. So the side, angle, side congruence theorem says that if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of the second triangle, then those triangles are congruent. So for this diagram that I drew up here, let's call it A, B, C, and D, E, F. I can say that triangle ABC is congruent to triangle DEF. And just like before, order matters. Notice that angle A and angle D are the ones that are congruent. AB and DE are the side lengths that are congruent. And then that means EF and BC should be congruent, okay? So I need to make sure that my statements are the same in both, okay? So side, angle, side says that as long as you know those 3 things, you can say that the triangles are congruent. And why does this work? This works because if you take 2 sticks and you tape them together at one corner at a certain angle, and then you take 2 other sticks that are exactly the same as the first one, and you tape them together at that same exact angle, only one size stick will fit in between to connect those 2 legs. And that size stick is going to be connected at the same exact angle. I know that that's like a really weird example, but like if you think about it, or if you go outside and grab 2 sticks and you stick them together, you literally can only put one final stick in between the 2 of them to make it connect like a triangle, okay? There is only one other way to do it. So side, angle, side proves congruence. All right, that's it.